For this next part about curve sketching in 3.6, we're going to look at a curve and identify some locations where things happen. So we're going to look at part 1, and we're going to locate a point on the curve below such that the stated conditions are met. If there is more than one point, list them all. So lots of points on this graph. First, I want to find when f of x equals 0. That occurs here at G, K, and P, and V. Next, we're looking when the derivative is greater than 0. That would mean the function is increasing. Increasing has to be on the interval. C and D are on the increasing interval. B, it's in, I would say, the closed interval of the increasing region. So you could say it's increasing from this x value closed to this x value closed, but that point is not. For that point to be in there, we would have to look at just to the left of it, is there a point higher? So B and E are not included in this. So C, D, J, K, L, U, and V. C, the first derivative is greater than 0, so increasing all of these options, and the second derivative is greater than 0, which is concave up. So out of these options, which ones are concave up as well? This wasn't mentioned in the problem, but it should be noted that C, F, L, O, Q, and S are inflection points, points where the concavity changes, and therefore it can never be concave up nor concave down at those locations. So C is an inflection point, it can't be concave up. D is concave down. J, which is right here, would be concave up and increasing. K would be. L is an inflection point, and U and V also would be. Next, we're looking for when the derivative is equal to 0, which would be a max or min, and when the second derivative is less than 0, which is concave down. So that means a max. We're looking for the maxes. So that looks to be at E, M, and that's it. E, when the second derivative is equal to 0. Those are possible inflection points, or the actual ones. So all these blue circled ones are my possible inflection points right there. All right, F, when the function is 0, already had that happen up here, and the first derivative is greater than 0, which is increasing. So out of these options, where is the function increasing? G is decreasing, K is increasing, P is decreasing, V increasing. So K and V. G, when the original function is less than 0, so below the x-axis, and the second derivative is equal to 0, a possible inflection point. So our inflection points that would be below here would be Q and S. H, when the first derivative is 0, so a max or a min, and when the second derivative is equal to 0, which would be a possible inflection point. This is where we're looking for a saddle point, derivative equal to 0 and second derivative equal to 0. So a saddle point is going to be right here. It's a point of inflection, and at that point the derivative would be 0 at Q. I, which I think is the last one. The derivative is less than 0, which would mean decreasing, and the second derivative is less than 0, which would mean concave down. So we're decreasing and concave down. Here's decreasing but concave up. Here's some concave down stuff but still increasing. Now we're concave down, but that's an inflection point. And now we're concave up, so we have to skip over all of this. Here we're concave down and decreasing at n, so that's our first value. Concave down and inflection point. So now I have to get out of this concave up piece. And here's concave down again and decreasing, so that'd be R. So N and R. And then we inflect back to concave up. So N and R. Next, we're going to look at a sketch of a function and graph the first derivative and second derivative. So the first thing I'm going to do is I'm going to draw some lines down from A, B, C, D, and E, because those are the points I need to have plotted on my new function. So I tried to do my best here to get the lines on. And now what I'm doing is I'm making sure that I have my derivative where it's going to equal 0, and my second derivative where it's going to equal 0 plotted. First derivative is going to be 0 where I have maxes and mins. So at A, I will have a 0 on the derivative. C and E, I will have 0 on the derivative. B and D are inflection points. So at B, my second derivative needs to be 0. At D, my second derivative needs to be 0. And now the rest of it, I'm going to sketch in. This is all increasing. This is all at positive slope. That is where the derivative is positive, and it will hit 0 there. Then the derivative is negative until I hit right here. And that's where the slope is the steepest. So that is actually going to be a minimum on the f prime graph. So I'm going to hit my lowest point where B is at. And I'm going to curve my way back up. So at C, I'm at 0 again. D is another inflection point. That's where the slope is the greatest on this interval. So that's going to be the greatest f prime value. And then I got to get back down to 0 here for E. Oops, I missed it just a little bit. But positive slope, positive first derivative. Negative slope, negative first derivative. So now I'm going down here. Really, I'm using this first derivative function and doing the same thing that I just did. Here I have a negative slope the entire time until that point. So I have a negative second derivative until that point. Now here I have a positive slope until where D occurs. So I need to be positive, and I will be at my highest positive right here, where I have the point of inflection on f prime. And then I'm going to curve back down to hit 0 where I need to, which is at point D. And then from point D all the way out, I have a negative slope, so a negative second derivative. So this would be better if it looked like a nice parabola, but I have something similar. So here I have all my points kind of labeled. All of them are on the first derivative, but B and D are the ones that need to be at certain locations for the second derivative. C, also a good one to put on there because that's the max. A and E are just going to be over here somewhere on their appropriate sides of the parabola. And there you've sketched your derivative, knowing the first and second with the original function.